Hello and welcome to episode 8 of our language design exercise. We're using the OHM language library to design a programming language interactively. Right now, we want to add some async code. We're going to add concurrency, not with threads, mutexes, and locks, but rather with the await formulation, which is popular in many modern languages, such as, for example, JavaScript. If you've written any JavaScript program, you're probably familiar with the way that you can fetch content from a URL. That's an asynchronous call in JavaScript. It returns a promise of some sort. So you can assign it directly to a promise object, and then you can await that promise, getting back a response. Sometimes this is written not necessarily in 2 steps, but rather in one where you await the call directly. Because after all, fetch right here is returning a promise, which can then be awaited. After doing this, it's common to turn that response, which is in JSON format, into some sort of an object, and you have this, which is also happens to be asynchronous. So you see code that looks like this a lot in JavaScript. You might want to do the same thing in the language that we're developing right now. Let's try to build up a version of this. So I think what we want to do, first of all, is we want to introduce the keyword await as a unary operator. Remember, sometimes you can await a call, but sometimes you can await a variable. Let's set up so you can await any expression whatsoever. Or, I mean, maybe not. I mean, maybe the right thing to do is to say at the top level expression, we could await. What is it that we can await? How about, should we await any kind of expression whatsoever? Await an expression. It's one thing we could do. Another thing we could do is try to say, oh, the only thing you can await is an ID or a call or something like that. I think let's just go with simplicity. Let's just await an expression. And what we'll do is we'll leave the rest to type checking. So await expression, this will just be an await expression, okay? Now, great, we now have awaits in our language. And if I put semicolons in here, we should find ourselves with code that passes, but we do not because await needs to be a keyword. Await is now going to be a keyword in 1 second. The language is getting big. Is that good or bad? I don't know. Ta-da. Got to spell it right. And it works. Great. We now have code that can await, and we can also do things where we first assign to a promise object, and then we can follow that with a R is await P. All right. So await is now in our language, but our language is supposed to be statically typed. What is the type of fetch of URL? I mean, we're imagining that we can write a function called fetch, and what should it return? It looks like it takes in a string. We know that much, but what does it return? Well, it's supposed to return a promise that will eventually resolve to a string. So I know there are some languages where promise string is the way you would write things. We don't have these fancy little angle brackets in our language just yet. So let's experiment a little bit. What's a good symbol that looks like async? Caret, maybe? Maybe we'll go with a string caret, and that will represent a promise resolving to a string. If I do that, I'll have to go look for types, and probably right under here, define another kind of type, a promise type, to be one in which the type is followed by a caret. And we'll go with promise type here. And it's green. So that's good. So we now have types, which are promises, and we have an await keyword, which remember, and we're just doing syntax right now. So when we do the semantic analysis and type checking phase of a compiler, we'll handle all that good stuff at that point. We should talk about how we create promises, though. I mean, if I did have something like this like what exactly would I return? Would I return a string like hello and have it automatically? Should this automatically then produce a promise? Or should we be more specific in how we say, here, make a promise out of this? Well, you've probably seen in JavaScript and similar languages that they have a kind of they might have a resolve function. I think you write it something like this in JavaScript. You say promise dot resolve. If we want to have promises a little more built into our language, we could try this. We can make like a resolve operator. And what the resolve operator would do is it would take an object of some type T, and then produce a promise of type T as the result of the operation. I kind of like this a little more than doing a function. I mean, we could imagine that there was a resolve function inside our standard library, which would take an object and produce something of that type. And I mean, that works too. So there's a language design question here. Do we want resolve? And with resolve, there's always a reject, right? If you want a failed promise. Do we want resolve and rejects to be operators, or do we want them to be built-in functions? And either way works for me. If we want to keep our grammar a little bit smaller, we can just assume that resolve and reject will be built-in functions. So we can leave it at that and let this thing work. All right. So if we ever need to create a promise, we just go with resolve. And possibly reject as well if we want it to fail. So we can imagine our code looking something more like, you're doing some work over here, got some work going on, and then, if some condition holds, I don't know, if true, then we can return the resolve of yes, or we can reject with, or we can return rejecting with no, something like that. Okay. So our promise will resolve to a string. But what if it rejects? What should we reject it with? That's a good question, right? I mean, should we always have the type that you resolve to be the same as something you reject? Or should we just, I know what we could do. We can just say reject can be anything whatsoever, because it's not always going to be a string. We should allow reject to take in a parameter of anything kind of implicitly, and then we won't have to change this. But it does mean that if we have a function that we know is returning a string promise, I should say, then what? How do we actually call it? Okay, well, if fetch is returning a string promise, then await fetch of some string s should return a promise. Okay, we can assign that to fetch returns a promise. We assign that to p. And then this is going to be some string, right? Remember, fetch returns a promise, so we can do like that. But if we await the promise, then we're getting the string out, because await will take the resolved object out of the promise. It's going to wait for the promise to be fulfilled, and then it's going to take the string out. But what happens if this promise that fetch returns was rejected? How are we going to know whether something is, if the promise was, fulfilled properly with success, or if it was rejected? Well, here's where we might want to go with the standard try catch from from JavaScript, say, right? In JavaScript, you would write something like this, and then you would catch the rejection object. Maybe we'll just call it E, and then we'll do something with E, like so. This is something we could try. No pun intended over there. Whenever we await something, we can get the value if it's fulfilled with success, but if it fails, we can drop down to catch. And this structure is used in JavaScript. It's very nice. You can have as many awaits as you want. All the awaits will fall into the catch if any of them are rejected. So I think that's actually doable. So why don't we make a new statement, a try statement, where we try a block, and after the block we have a catch, and then we have, I guess we just have params, right? That params is our parenthesized list of things, and then another block after that. I guess that did not turn out to be so bad. And that's our try statement, but we do need try and catch to be new keywords. We're getting a lot of keywords now. Try is try. On them. Catch is catch, non-alphanumeric. And try and catch down here. Try catch. Let's see if we get this green yet. This is refusing to be green because a semicolon is expected after that E. We have try, a block, a catch. Let's move this out of the way. Let's focus only on our try. Try is a statement. It's a try statement. Try block, assignment statement inside. Within a wait, getting kind of hard to see. Let's try folding it. Having a hard time seeing what this actually should be over here. Oh, catch needs parameters. That's what it is. So E's going to be, yeah, if we make this params, then we'll have to write something like this where E isn't anything. I suppose if we kind of knew that fetch was going to throw something of a different type, we could put that type there. But again, this is more stuff that we get to leave to our static analyzer, to our type checker. But right now, let's write it like this. If we knew it was going to be an integer that it was going to throw, then fine, we could try something like that. All right, but yeah, for right now, I think anything should go there. We can think about whether or not it would be appropriate to not have the type on there. But I think if we do type it, it's good because then we can use objects with the type that is expected right here. All right, so we have the rudimentary await mechanism there. If you're wondering about whether or not we need an async, again, we're just designing. I mean, maybe we don't need to say async because, you know, JavaScript allows await at the top level. But if you do put await inside of a function, it has to be inside of a function marked async. But you know what? We're going to design right now without it. And then when we do semantics a little bit later on, we'll go back and revisit it if necessary. I think the last thing I want to do right here before we move on is deal with the idea that a whole bunch of promises can be put into an array because a bunch of async functions are all running at the same time. And we want to be able to wait for the first one to finish or wait for all of them to finish. So if we are experimenting with some language design things, let's imagine we have like three promises, P1, P2, and P3. And somehow or other, we'd like to launch three async functions at one time. So perhaps I did something like P1 was, we launched an async function called, I don't know, async function 1 with some parameters. And then we did the same with like P2 and P3. This is kind of ugly, but you get the idea. I'm launching three asynchronous functions, right? They're all going off. I got these three promises. And how might I wait for all of them to be done? Well, we might extend our await so the wait could take in an array of P1, P2, P3. And what should that mean? Does that mean we're getting all of them or we're just getting one of them? I mean, we do have to assign a response to it. So like, what would that mean? Should that be the first one or should that be all of them? I mean, I suppose we could imagine saying await 1 we can use a keyword one, or we could say await all of them. If we do await all of them though, then our result is going to be an array, which is okay. I mean, we can assign it to, we can assign it to R, we get an array of results. So we can await all of them, or we can await one of them. Do we want new keywords for one and all? Or should we just say, or should we use some syntax over here? Like await star, that means all of them, and await, I don't know, question mark? I don't know, would be one of them. Await caret one, await, you know what? Language design is hard, but that's what OHM lets us do quickly though. We can type stuff in here, see how it works, plug it all in, and try things out. I'm interested in what looks interesting. I mean, I don't really mind await one and await all. They're both useful. I don't want to say await any because, you know, any is a keyword in OHM. Which not that you should let that have anything to do with your choices in your own language. Just something funny to think about. Await one, await all. Yeah, I mean, let's try it. I mean, we can use one and all as keywords. I don't think that'll hurt too much. Where do we put await? So await, and then optionally speaking, we could use the word one or the word all. I think this will do for now. I mean, again, remember, we're just designing. Await one, await all, and then over here we'll put in one and all, and then one and all. More time is spent typing this stuff in. A lot of other things. Okay, one and all. And just put a semicolon in here. So it works like this. Does it work with one? Yes, it works with one. Does it work with all? It works with all, but it does not work with dog, nor should it. Yep, good, that fails. As it should, we should not be able to await a dog. Though we do want to be able to say await one of some array of promises. That should be good, which it is. Anything else about async used this way? Yeah, there is one thing. There's this idea in asynchronous computing where you can fire off an async function and wait for it to complete with a wait, and then if it it'll finish, or it'll be rejected, it'll be resolved, and then you can continue. But there's also this idea that you could wait just a certain amount of time for that thing to finish, and if it didn't finish in time, you could pretend that it was rejected. So I'm thinking something like this. You might await some call that is going to be async. So F is async, and normally you would wait for this thing to return a response, and then you would continue, right? Or if this was in a try catch, either the thing's going to finish or it's not. Let's say it rejects with a string error message or something. Okay, and this is all good. But what if we would like to say something like, hey, you know what? I only want to wait 5 seconds for this thing to finish. And if you're not done in 5 seconds, I'm just going to fail it. So I can imagine something like you put in this little timeout over here and say, all right, well, I'm going to wait, but only 5,000 milliseconds or something. And if this doesn't work, it's going to be rejected. The interesting thing here is that it's not really a catch, because it's not that this thing was rejected, it's that it timed out. So we have a catch here for a failure, but maybe we want something for a timeout instead. And so maybe maybe, I don't know, again, remember just designing, we'll talk about a timeout. And maybe the timeout should go, here. Like if you timed out, then you can run some code here. All right, so I don't know. I don't actually mind this very much. I think, as far as design goes, it probably doesn't hurt to have in here. Of course, it does mean that we have a new keyword called timeout. On timeout, if timeout, timeout. It's worth a shot. I mean, not that I haven't seen it before. I just added a lot of keywords here, didn't I? But what are you going to do? Not working over here because await needs to have its little time thing in here, right? So caret exp, not caret, sorry, but angle bracket. Then possible an optional one or all. And our try function will optionally have a timeout. So right in here, there's going to be an optional timeout followed by a block. And that, oh my gosh, that does not make it green. Why does that not make it green? We have a try, a block, a timeout, and a block. What's my block? Oh, I have an error over here because I'm sloppy. That needs to be a parenthesis. Still not good over there. We have an await. We have a, how we doing here? Angle bracket, expression, angle bracket, one or all. And we have an expression, and this is my expression right here. At the end of the assignment. This is an interesting error right here. Wait. Boom, boom, boom. Put arguments in here. No arguments. It's not helping. It thinks it wants a little bit more over here. So there's something it's a little unhappy about. Wait expression. Well, this is an expression here. Was this working without the timeout earlier? Or is the problem with the problem seems to be with these? Oh, it's actually, oh, did I not make, oh, I did not make this optional right here. I was requiring that. Okay, that's one problem. All right. So let's see if the timeout works. The timeout works, it does. And now let's see if I can put this back 5 seconds for half a second. No, there's still something wrong here. Right after the 500, a greater than over there. Okay, I do know what's happening over here. This is a good way to, good time to visit grammars. I see this 500 and then I see this angle bracket. What's happening is that in ohm, we see the first angle bracket, we see the expression, and we're trying to parse an expression, and we see first a 500, but we're kind of going down to, kind of moving down after we see the 500 to this world right here. And when I see a 500 and a greater than, it looks like I'm actually starting to do a 500 greater than something, maybe 500 greater than 2. Angle bracket, that kind of worked, right? Because this, the first angle bracket, the first right angle bracket here, this was looking like it was a greater than over here. And then it finished up the expression, and then it went to one of these. So we got to do something interesting over here, right? This angle bracket right here, how do we distinguish this angle bracket from being the closing angle bracket for the timeout? Quite an interesting little problem. I think that if we should probably do some kind of a look ahead thing over here, right? I mean, actually, do we ever want something? Should we want this? We definitely want this to happen. But what about how do you think we want to deal with, making sure that that angle bracket in the grammar is not something like this? So once I get this and I get this, crazy, huh? 500 to the 2, 503, less than 2. That works. This is crazy. This is a little bit unexpected over here. Why do we want to do grammarize here? This is a series on ohm. So let's see. Look at all those things that can be. I really just want to close it off. That doesn't work. Something needs to be here. Very interesting. See, look down here. Here's our expression. Conjunct, disjunct, conjunct. Why, when we saw a comp? Yeah, you know what? It sees the comp. It commits to that thing. We should be able to somehow or other back it off. Maybe to say that the 500 angle bracket is not far away or Don't want it to commit to that. Funny. Anything we put in there is fine, but it doesn't like that. Well, we can either try to get fancy with the grammar and have it. Well, I guess we could do this. We could say, this gets pretty messy, but we can say, all right, only go in here, only dive down here if you know that there's a comp after it. So we could say, this is going to be terrible. Oh, actually, it's worse than I thought, right? Because look, 500 greater than F. Here's what's happened. We see the 500. This is 500 greater than F. Oh, this greater than is very, very unhappy. We're going to need a lot of parser machinery to understand that, which is why we might want to consider just using braces, although braces could get us confused with a dictionary or something like that. This is pretty wild. So what if this was just an expression, then we would be awaiting the expression. So some kind of interesting mechanism would need to be used here. Perhaps it's a, you know what? I think that can do it. Let's get fancy with the double angle bracket. If it works, it works. All right, double angle bracket it is for now. Okay, I think what I want to do right now is call the language design, as of right now, fixed. And in the next episode, we're going to change things up a little bit, and we're going to move toward how do you take ohm and embed it into a command line application rather than just using the ohm editor. And that's what's up for next time. We'll do ohm semantics. Bye.